Documentary. The moon hangs in the night sky, a silent sentinel that has captivated humanity for millennia. Its pale, cratered face has inspired myths, guided navigators, and fueled scientific curiosity. As a documentarian, I invite you to embark on a cosmic journey, a sweeping exploration of the moon from a spatial perspective, weaving together its geological origins, cultural significance, scientific discoveries, and future potential. This is not just a story of a celestial body, but a projection of humanity's relationship with the cosmos, told through the lens of our closest neighbor in space. Imagine the early solar system, a chaotic cauldron of swirling gas, dust, and molten rock, some 4.5 billion years ago. The Earth, still in its infancy, was not alone. A rogue protoplanet, roughly the size of Mars, and later dubbed Theia, hurtled through the nascent solar system. In a cataclysmic collision, Theia slammed into the proto-Earth, ejecting a colossal plume of molten debris into orbit. This violent encounter, known as the giant impact hypothesis, gave birth to the moon. The debris coalesced, cooled, and solidified, forming a glowing orb that would forever orbit our planet. This origin story, pieced together through decades of scientific inquiry, reveals the moon as a relic of cosmic violence. Its composition, rich in silicates and lacking in volatiles like water, bears the scars of its fiery birth. Unlike Earth, the moon has no atmosphere to erode its surface, preserving a geological record that stretches back billions of years. Its craters, some as old as the solar system itself, are time capsules etched with the history of countless impacts from asteroids and comets. The lunar maria, dark basaltic plains formed by ancient volcanic eruptions, contrast starkly with the brighter, heavily cratered highlands, creating the familiar man-in-the-moon pattern visible from Earth. As we zoom out to a spatial perspective, the moon's formation is a microcosm of the solar system's turbulent youth. It is a testament to the dynamic processes that shaped planets, moons, and asteroids in the early cosmos. The moon's gravitational tether to Earth stabilized our planet's axial tilt, fostering a climate conducive to life. Without this cosmic dance, Earth's seasons might have been wildly erratic, potentially altering the course of biological evolution. The moon, then, is not merely a passive companion, but a silent architect of life as we know it. From our vantage point on Earth, the moon has always been more than a rocky satellite. It is a canvas for human imagination. Across cultures and epochs, it has been a deity, a guide, and a symbol of mystery. In ancient Mesopotamia, the moon god Sin was revered as a divine arbiter of time, his waxing and waning dictating the rhythm of religious festivals. The Greeks saw Artemis, goddess of the hunt, in its silvery glow, while in Chinese mythology, the moon is home to Chang'e, a lunar goddess exiled to its desolate surface. Even today, the moon's phases inspire poetry, art, and spiritual reflection. This cultural reverence is rooted in the moon's omnipresence. Unlike distant stars or fleeting comets, it is a constant in the night sky, its cyclical transformations mirroring the rhythms of human life: birth, growth, decline, and renewal. Ancient mariners used its light to navigate uncharted seas. Farmers timed their harvests by its phases. The moon's gravitational pull governs the tides, a subtle reminder of its physical influence on Earth's ecosystems. Yet the moon's allure extends beyond the tangible. It is a symbol of the unknown, a beacon of the unattainable. In the 19th century, Jules Verne's From the Earth to the Moon imagined a cannon-launched journey to its surface, capturing the era's burgeoning fascination with space. This literary vision foreshadowed the technological leaps that would make lunar exploration a reality. The moon, from a spatial perspective, is a bridge between Earth and the cosmos, a stepping stone that has long tantalized humanity with the promise of other worlds. Fast forward to the 20th century, when the moon transformed from a distant muse to a tangible destination. The Cold War's geopolitical tensions fueled the space race, a contest of technological supremacy between the United States and the Soviet Union. The moon became the ultimate prize, a stage for demonstrating human ingenuity and ideological dominance. The Soviet Union struck first, landing Luna 2 on the lunar surface in 1959, the first human-made object to reach another celestial body. The US countered with ambition, launching the Apollo program under President John F. Kennedy's bold directive to land a man on the moon before the decade's end. On July 20th, 1969, Apollo 11 achieved this dream. Neil Armstrong's words, "That's one small step for man, one giant leap for mankind," echoed across the globe as he stepped onto the Sea of Tranquility. From a spatial perspective, Apollo 11 was a triumph of precision and courage. The journey required navigating 384,400 kilometers of vacuum, landing a fragile craft on a rugged, airless world, and returning safely. The astronauts collected 21.5 kilograms of lunar samples, revealing basalts and breccias that confirmed the moon's volcanic past and ancient age. The missions that followed, Apollo 12 through 17, expanded our understanding, mapping the lunar surface, deploying scientific instruments, and even driving a lunar rover across its dusty plains. Yet the Apollo program was more than a scientific endeavor. It was a moment of unity. For the first time, humanity saw Earth from afar, a fragile blue marble suspended in the void. The iconic Earthrise photograph, captured by Apollo 8, underscored our planet's vulnerability and interconnectedness. The moon, once a distant dream, became a mirror reflecting our shared humanity. The Apollo missions were just the beginning. Decades of robotic exploration by the US, Soviet Union, China, India, and others have deepened our understanding of the moon's mysteries. Orbiters like NASA's Lunar Reconnaissance Orbiter, LRO, have mapped its surface in unprecedented detail, revealing hidden lava tubes, polar ice deposits, and evidence of recent geological activity. Landers and rovers, such as China's Chang'e 4, which touched down on the moon's far side in 2019, have probed its composition and structure. One of the moon's greatest enigmas is its asymmetry. The near side, visible from Earth, is dominated by maria, while the far side is a rugged expanse of craters and highlands. This dichotomy, scientists hypothesize, may stem from differences in crustal thickness or tidal locking, which keeps one face perpetually turned towards Earth. The far side, shielded from Earth's radio noise, is also a prime location for future radio telescopes, offering a window into the universe's earliest moments. Water, once thought absent, has emerged as a key discovery. In 2009, India's Chandrayaan-1 detected water molecules in the lunar soil, and subsequent missions confirmed ice in permanently shadowed craters at the poles. This resource could sustain future human exploration, providing water for drinking, oxygen for breathing, and even hydrogen for fuel. From a spatial perspective, the moon is no longer a barren wasteland, but a potential oasis, a stepping stone for deeper space exploration. The moon's geological story also sheds light on the solar system's history. Its ancient surface preserves evidence of the late heavy bombardment, a period of intense meteorite impacts around 4 billion years ago. By studying lunar rocks, scientists have pieced together a timeline of cosmic events, from the solar system's formation to the impacts that shaped planetary surfaces. The moon, in this sense, is a cosmic archive, its craters narrating a story of chaos and creation. As we stand on the cusp of a new era, the moon is poised to reclaim its role as humanity's gateway to the stars. NASA's Artemis program aims to return humans to the lunar surface by the late 2020s, with a focus on sustainability. Unlike Apollo's brief visits, Artemis envisions a lunar outpost, the gateway, a space station orbiting the moon, and a permanent presence at the lunar south pole, where water ice is abundant. This ambitious plan seeks to establish a foundation for long-term exploration, testing technologies for future missions to Mars and beyond. Private companies are entering the fray. SpaceX, Blue Origin, and others envision lunar bases, mining operations, and even tourism. The moon's resources, helium-3 for potential fusion energy, rare earth metals, and water, could drive a new space economy. However, this rush to exploit the moon raises ethical questions. The Outer Space Treaty of 1967 prohibits nations from claiming sovereignty over celestial bodies, but its ambiguities leave room for debate. Who owns the moon's resources? How do we balance scientific exploration with commercial interests? These questions will shape the future of lunar exploration. From a space